So welcome to the Kimberton EcoVillage discussion group. Today we're going to be limiting our focus on the passive house. We're not going to talk about alternative energy and how we're producing our energy. We're not talking about our site or any of that. We're focusing on the building techniques. And I've invited two wonderful people to join us. Ilka Cassidy, who is an architect. She went to the largest school in Germany, the technical high school in Aachen, and then came to University of Washington, and came to Philadelphia about 15 years ago. So she's worked in architecture firms. She's now a certified passive house consultant and a member of the Green Building United. It used to be called the Delaware Valley Green Building Council when I was involved back in 2000. She is very passionate about the passive house, the envelope design, and the building science, and is very involved with many projects within the Philadelphia region. Steve is more a timber guy, structural designer, and has formed a team along with Hugh Lofting. Now, if you've been to the Y in Phoenixville, you've seen the entrance, this incredible timber structure. He's been with Hugh Lofting since 2008 and is now working with let's see, you guys have one other partner with the Holzraum Systems, and I will let you guys describe it. It's certainly a 21st century concept of a business. Does quite a few things, including education, which is one of the reasons both Ilka and Steve have chosen to join us, because we're in the business of educating. So as I go through this initial set of slides, which is going to try to introduce the concept of passive house, any comments you have, Steve or Ilka, to make would be appreciated. I've been working on passive house, but not passive house from Germany, which it came over about, I guess 10 or 15 years ago. Ilka, correct me if I'm wrong, but
yeah, around that time.
Passive house has been around since people started building, which goes all the way back to prehistoric times. We will get into a little bit of that. We'll show you some of the 21st century passive house concepts. Here at Altair, we've been working on passive house for several years, and we've visited some of Pedranti passive houses. This is Richard Pedranti in the area using the Build Smart system. I'm also going to be showing you, as far as I know, and I was hoping somebody from the National would be on, I think the only passive house co-housing development is in Belfast, Maine. There are others we are looking at in Charlottesville, North Carolina, and there may be others, but that's the one that we visited. I want to show briefly what other countries are doing with the passive house systems. Jonathan and I met Steve and Ilka at the Passive House Institute conference in Washington. It was to say the least, evangelical for me. I don't know how it was for you guys, but it's just amazing when you get people together and start talking about passive house. And that's going to be a topic for another conversation, because we really don't have enough time to go into every aspect. I will be showing some of the Passive House Institute examples very quickly, and then we'll turn it over to them for the local Holzraum system. So going back to the 70s, I'm only going to show you a couple innovations. One was this attached day space, commonly known as a sunroom, and this was an idea that came out of the 70s. I don't know how many people have seen this. You heat up a space during the day, and then at night, this heat that you collect in the wall radiates throughout the house. Here's another concept, and I'm telling you, this was over the top for me. It's an entire wall of tubes filled with water, and
We're frozen, it seems.
Mm.
we're going to be facing to the south. We're going to be berming as we can. Unfortunately, our site is reversed, but we've done a lot of work. In fact, if you go to Steve, you are in West Windsor. If you go to East Windsor, their municipal building is underground, and they have, it's kind of funny. It looks like a hill, but it's their municipal building, completely green roof. Putting the deciduous trees on the south, smaller north windows. One principle used very often is to have dark floors, like black slate. So when the sunlight comes in, it radiates and the heat is collected on the floor, and then you close the windows. And I had one house that they didn't even need the heat at night. We collected so much energy in the floor, and then we moved the air through the space. Another house we did in the Caribbean required no heating or air conditioning, all natural, but that's the Caribbean. So I'm moving quickly into the 21st century passive house. Compliments of Richard Pedranti. These are your 5 principles. Jane, this is Passive House 101. You asked here the first principle is what we just talked about, to orient the house properly so it maximizes the amount of sun coming in. The second is to have incredible amounts of insulation. I'm not going to go into detail. Everything we're doing in this slideshow and elsewhere, it far exceeds what's in the code. We also have a great deal to talk about with windows, and we're basically going to be talking about using a high quality triple glazed window. I'm designing a warehouse now where we have single pane industrial windows, and even putting a double pane insert does not come up to the energy code required now by code. So that's a tough one. Airtight enclosure, this is the essential component that makes the whole thing possible. And you'll see the blower door test there, right? When we visited Mosaic Commons outside of Boston, the residents did the blower test, and you can bet the builders paid attention when the residents did the test. And here's the last one, which is the mechanical, and we're going to go into a lot more detail about that. This is where the real energy modeling comes in. Very efficient and small ventilation and recovering the heat. So here's some of the things that Richard Pedranti has done. And one of the reasons I went to the national conference, and I'm sorry, no disrespect to Richard, but I wanted to see if we couldn't do something a little bit more architectural looking. And Ilka, you know very well what I'm talking about with some of the revision architecture models where the engineers have the say. These are all passive houses. They're all single family. We're going to be looking at some other models here. these are, this is one we visited nearby along Route 100. It was under construction, but you really got a feel for it. How many people remember this house? Jonathan remembers. Sue remembers, yeah. Richard does his modeling and showing the performance. These walls were 10-inch of insulation thick. Here's the water heater. Here's the ERV. Very small mini split. One head upstairs, one downstairs, and the space felt you know, livable and nice, but quite frankly, it was kind of overkill in terms of the energy modeling and more expensive than we needed. That was our conclusion. I won't go into detail, but this shows how the envelope is controlled. You see the pink line here. That's the important line that is the air vapor barrier control layer. And this is a design where the insulation is used as a formwork. There are a lot of different variations of this. This is something that people have studied a great deal, and this is the secret to the passive house, are these edge details. Otherwise, you lose everything. We are planning slab on grade, not crawl spaces. Here's Belfast. And again, we think our architecture can look a lot better than this. Ahem. This is the common house. Here's some models from around the world. This is the main factory where the Belfast was produced. The people involved with the co-housing also built other passive house. It's a panelized system, as you can see, and they did invest in the factory. Jonathan and one of our civil engineers visited this plant and can do a more thorough report. The Build Smart system is very much in use around here, and the one that we've been looking at. In fact, there's a project only about 10 miles from us, the Whitehall community. This is, I love it. This is so cute. The Japanese model here. This is all prefabricated, and they use a system that has this polystyrene. When we get to Holzraum, you'll see that we are now going to be going to, it says eco-friendly, but we can do better than this. Right, guys?
That's true.
Yep, okay. Here's what I'm not talking about today. Jeremy Rifkin was our keynote speaker. He wrote a book called The New Green Deal, which is an urgent plan to confront climate change, transform the American economy, and to create a green post-fossil fuel culture. Jane, does that sound familiar? That's what Jeremy Rifkin is doing on an international scale. He is an absolutely incredible speaker.
We must read it.
Yeah, set the tone. This is not Bernie Sanders' New Deal.
Yeah, okay.
This is Jeremy Rifkin's Green Deal, which is much more expansive. I went there to see the aesthetics and the design, and I came away with some examples, which I'll show you. We have to talk about marketing the passive house. this is huge, you know. People don't know what it is. Why should they spend more? What are the advantages, disadvantages? This is what you're going to be addressing shortly. There's going to be a lot of technical stuff. We're going to lose you guys. You're going to engineer us to all over us with the Holzraum system. I won't go into that right now. And Ilka is a specialist on the glazing innovations. Boy, what a big topic this is. Air quality, this is the main reason to do passive house, and there are lots of studies on that. And then environmentally friendly materials is something that our members asked for 3 years ago. They were scared of the Build Smart system. I think we're answering it now. Do we go with panelization modular? You're going to bring that up in your slideshow, so I don't need to talk about that. The codes we're working on, I think Washington State is the furthest along in terms of actually introducing some of the passive house principles into building codes. I'm going to show a little bit about modeling cost savings. That's a group out in Portland and Washington that we met at the conference. We've spent a lot of time talking about grids and zero energy. We will be talking more about that. That's a huge topic. And then we have our how to appraise the passive house. What are banks going to say? You know, are we going to get mortgages, some kind of green mortgage break for doing what we're doing? Those are all, this is a huge topic, and there are people specifically working on training appraisers. Did you guys attend that session down in Washington? That was,
I think I did.
yeah, fascinating. There are people writing, training appraisers. So here are some of the winning entries, and please, this is going to go by very fast, but just take a look. This is these are the some of the winners, and I'm showing this because we have some aesthetic differences here. We're going to be able to show you. Oh, you want to move this over? Okay. Anyway, this is Canandaigua, and this is a big development using passive house design. It looks a little like suburbia with single-family houses. We do have some twins and so on in this model, but this was praised for its efficiency and so on. Here's a modern contemporary house. And this, again, this kind of architecture was simply not available 3 years ago. We didn't see any passive houses that looked this sharp or this smart. And take a look at this one. This is a wonderful single-family house. This is cute, the bicycle house. These houses are designed to be put sort of anywhere, which, Ilka, that goes against my grain as an architect. I always spend a lot of time with the site before I plop down a passive house, just, you know.
Yeah.
Here's a townhouse. This is Chicago, affordable multifamily. Affordable multifamily is a huge area of progress. And we have 2 projects here in Phoenixville involving passive house, affordable multifamily. Here's a townhouse. This is actually sandwiched in between fairly traditional housing. You might question the architecture, therefore. I've seen better integration of the old and the new, but they didn't have to. This apparently was not in an historic district or whatever. These are all certified passive houses. We have models in Philadelphia that we can go see as well. Okay, this is the cost-efficient design, and I don't want to spend a lot of time on it, but there was a study that he did that he showed. This was one of the big talks in the big auditorium. You take a typical unit and you see where you can maximize it. So he's got the typical plan and optimized plan. This is the kind of study that we need to do in our co-housing to max out our unit design. There are dozens and dozens of unit designs, but just by doing some of this optimization study, I believe we can go a long way to bringing the cost down and improving the design and the use of the space. I don't know if Steve, you and Ilka looked at this, but I thought this was very useful.
Mm-hmm.
This is one of the townhouse projects, Habitat for Humanity. You know, it's functional, it's certified. May not be the style that we want in Phoenixville for sure, but here it is. This project is a little bit more to the point and has been studied, and there are examples of this in Philadelphia. Ilka, you're working on one now. This is about 5 years ago, but this is an excellent study that shows what you have to do to get certified and some of the considerations. Again, I'm not going to take a lot of time doing it, but this is what we're going to look at, and this is what you can expect of our architects and technical team. We're going to be looking at the various demands and the importance of the comfort. Passive house should be able to be at 50 degrees year-round with no heating or cooling brought in. Maybe that's improved now, I'm not sure, but here are the, now we're using hers. This is another one, Zero Energy Ready Home. This is 5 years ago. And here are some of the efficiencies that they put in their requirements. And these are some of the things that we're putting in our ordinance, okay? Here's some more. Indoor air quality is huge. Now if you look at these values, I mean, they're unbelievable. Look at this. A wall, 52, a roof, 90. I don't think so, not around here. This Columbia County is Ithaca, New York. You guys can speak to this. I think this is totally over.
Yeah, so what we see in our kind of zone here is more probably around like 36, an R36 for the walls, and then pretty much code an R49 for the roof, and then probably like 4 to 6 inches of under slab insulation. So it's not too crazy. This is definitely very different what we're looking at there right now.
But this shows the central design where you have a small amount of air being delivered into each space. And then you have the exhaust from the bathroom and they don't show the kitchen here, but basically your typical, this is called the central vent scheme, and they compared it with what's called the point scheme. And this shows, you know, ventilation through wall. And they compared these two. Very interesting. The point source versus the central. They compared it in terms of efficiency and cost and so on and so forth. Here's the upgrade. Jonathan, this should interest you. They compared the basic Energy Star specs for a house versus the certified passive house, and they came up with $26,000 more per home to go with the passive. And here are all the incremental costs by floor area and so on. This is extremely valuable.
This is 5 years old.
I know. It's 5 years out of date, but this, I'm showing this to indicate the kind of information we're going to need to make intelligent decisions. I don't think I should spend any time on your silver green. You have better slides of your floor plans, right? Here's the foundation, and that's the only foam I saw in the whole place. You might address this. It's nowhere near the residence or the air quality, so it's okay in that application. Correct?
Well, there is foam in. We are working to try to find strategies to get all of the foam out. Is a challenge downstairs in that house. Eventually there will be some residential space that is surrounded by the foam, and that's unfortunate. But right now we just don't have a strategy. Yeah, down in the basement, and the caretakers.
Okay. We met Shannon. She joined Revision, and this is a wonderful presentation. She was having another group coming in, so she spent a lot of time setting up, and we were fortunate to see the whole thing. You didn't bring the mock-up because you're not here, but talk about that. This is cool. This is what we saw down in Washington, and Jonathan pulled me over and said, "Hey, look at this." And I said, "Oh, wow, well, here we are." Now this shows you the cavity perimeter. This is different from the BuildSmart system. The BuildSmart system has the studs integrated, and this is another layer, okay? I'm telling you, as a carpenter for many years, that the quality of the lumber and the joinery, Steve, I mean, my God, this is unbelievable, you guys.
It won us over pretty quickly the first time we saw it as well. and the quality, the lumber actually is of a ridiculous quality. It's imported. It actually has a lower carbon footprint because it's container shipped imported. But what's great is, you know, anybody that is using North American, for the most part, any fabricator that's using North American wood is not really using like an FSC stewardship certified. And so what's really great is that all the lumber that comes through Blueprint is PEFC certified. And actually now they can do FSC too. So that's nice.
Well, you're throwing a lot of acronyms at our tender group here, but that's okay. Now, I was there when those guys downstairs were working with the windows. I never actually saw one installed, but this is key, and the difference between the BuildSmart and the Holzraum is that the windows are installed in the field, and I'd like you to address that as well. And then this is the downstairs you were talking about, and these are 2x on the flat. You can't see it very well, but there are little notches behind each one of these studs for the electrician. And if you look upstairs at the framing that I showed earlier, there are holes drilled, pre-drilled. So you don't have an electrician going around with a big right angle auger trying to struggle with this. All of the electric, you know, with pancake boxes and so on. Anyway, listen, I'm going to turn this over to you guys.
So we're Steve Hessler, and I'm Ilka Cassidy, and we started Holzraum System a little bit over a year ago, and I'm also an architect. I founded C2 Architecture, and I actually went to school in Germany And that's where I heard from about Passive House the first time. And then I moved here. I went to the University of Washington in Seattle as an exchange student, ended up working there a little bit. And then years later, I actually became a certified Passive House consultant. And that's been my passion ever since. Steve, do you want to say something about yourself?
Yeah, so my name is Steve Hessler, and I did a restoration carpentry apprenticeship after Penn State years ago, and so I've kind of been in the wood business, and I sort of got into designing heavy timber structures, and got picked up by a company that was one of the first. Actually, we had the first 5-axis CNC machine in the country 20 years ago, 25 years ago. And eventually I ended up running that design company, and I've been involved in structural wooden buildings and other parts of the building, all around wood and all around different fabrication techniques. So I kind of came from a very, rebuilding old things with hand planes to somehow moving into state-of-the-art CNC fabrication. So that's kind of where I like to be. And now Ilka and I started working together on high performance and passive houses together. And that's when we kind of came up with what we found out about some of these options that we're going to tell you about.
So Steve, I have a question for you already. When you study Japanese architecture and joinery, they can snap a curved line. Do you know how to do that?
I do not know how to do that, but I would love to study in Japan. It was a dream of mine to go.
Unbelievable. Yeah, the joinery there.
But they also hear that they make you learn just to sharpen your chisels for a year before they let you do anything else.
Thank you.
Right. So our presentation is going to be, we saw Joel's presentation and realized how much of a great introduction he's going to give about Passive House. So we're not really focusing on just Passive House, but if you have any questions about it at any point, we're happy to answer them. So our presentation is going to be just kind of a broader view on different options that we've worked with, and then what our goals as Holzraum Systems are, and then who we are, what we do, and our process, and how we kind of moved, for example, through the Silver Green projects from start to end. So yeah, so we found some cool images. So the way we build has been changing and needs to keep on changing, in regards to sustainability, health, energy efficiency, and cost.
Where is that slide?
This one?
Yeah.
I'm not sure actually, but I thought it was really cool. It's probably like Singapore. I feel like most of those come from there. But yeah, I thought that was pretty impressive, and it would be nice to have more of this around. Very biophilic. So this is bringing new opportunities. We know that by now the awareness is definitely rising. The building codes are slowly changing. We're at the 2015 for residential, 2018 for commercial in Philadelphia, which is gonna, change things drastically, and it's kind of changes the relationship to Passive House as well, because before, not too long ago, Philadelphia was still using the 2009 code, so the gap between a code home and a Passive House was pretty big in terms of, energy savings, but also in terms of cost. So now what's happening is that the building codes kind of they kind of catch up. And I think in California, I think partly the building code is almost at a higher level than Passive House, which is interesting. But so this means that buildings, people are just getting more used to building like the, you know, tighter homes, the just air tightness. I don't think anybody had really heard about that not too long ago, and now it's definitely a big topic. Mechanical ventilation, so things like that. So it's good for us because it's not as crazy. You know, people don't think it's as crazy when we start talking about these things because they've heard of it. And then the other opportunity is, you know, that the passive house solutions, it's been around for quite a bit now, especially in Germany, or in, I think Belgium is pretty big too with passive house buildings. And they are by now pretty proven and pretty adopted in Europe. And, you know, people here are definitely, I mean, we can see a big difference, you know, when people approach us about a passive house, like just the amount of people that know about it and are interested in it, it's definitely, you know, has increased over the last few years. Even the building industry, I mean, now you kind of hear things like, you know, even carbon footprint that we didn't hear even a year ago or two. So things are really just kind of moving into the, certain ways into the right direction. And it's definitely getting a little bit more cost effective. There's a lot more options out there. Like when we started, you know, just looking at the first passive house windows, I think I did that in 2014 or 15, and there was not much out there. Now there's definitely quite a bit of choices, and that, you know, makes the market a little bit more competitive. But then there are also challenges. So there's definitely still kind of a lack of contractors that are interested and willing to go the passive house route. They kind of know what they know, and you know, don't always want to tap into new things, learn new things, because what they've been doing is has been working out for them. Then new codes and methods, everything still, you know, still takes time to really be embraced. A challenge is definitely that the building tight homes has been gotten a little easier just with the zip system. You know, you just tape it and you can build a fairly tight home. But if you don't really build a tight home right, you can actually run into pretty big problems in terms of mold and air, you know, indoor air quality issues, because all of a sudden, if you don't ventilate your space right, you know, and you don't really, you know, set your dew points and everything right in your walls, you can definitely run into some issues, which doesn't really help the reputation of energy efficient homes. And then, of course, passive house is still, you know, it's still a premium. You know, it's definitely more expensive than building a code home. But as I said before, just kind of the gaps are closing a little bit. And I think that's the big difference, you know, towards like looking at passive house in Germany, because the codes are already so kind of high that the premium for passive house is actually not that much. And even if you build code, you're pretty close and you're building a pretty good building already. So these opportunities and challenges sending us onto the right path towards solutions. So Steve and I, we've been, you know, before we started Holzraum, we worked on several buildings together, as me as an architect and Steve as a builder, and we got the opportunity to definitely try out different solutions. And the first one to the left, it's a high performance house. It's here in Mount Airy, and we did it site built. The next one, we really wanted to try out EcoCore. We definitely liked their wall assembly, but the clients didn't have the budget to really go all the way towards passive house. So this is, you know, us trying to meet their budget and still implement passive house principles like air tightness. We hit a really good air tightness number, and then just really looking at detailing it right so that we didn't run into any issues because of thermal bridging.
Ilka, did you say EcoCore?
Yeah, that's what we want. That's the place that you introduced here to, the main place.
Okay.
Yeah, we did like their assemblies because it's a vapor open assembly, and you know that's what Holzraum is, or that's what our walls are. So we always liked the idea of it. This house, again, unfortunately, we were not able to use that system.
You want to tell them what those wall assemblies were for the high performance site built?
Yeah, so I think we had a pretty big under slab insulation. I don't remember, was it 6 inches?
6, no, it was 4 inches of under
4
slab.
inches, okay.
Foam under the slab, and then
Yeah.
a 2x6 wall with EPS,
Yeah.
zip sheathing and EPS.
Yeah, and then we made up for the roof had a very large R value. We Steve energy modeled this house in the beginning, and because it's only 1 story, has a really big roof surface, so adding quite a bit of insulation in the roof definitely helps the overall performance of the house, although the walls are fairly, are not much more than code. I mean, it has exterior insulation, but, regular 2x6 wall. Then the middle one, this is our certified passive house in New Jersey. And we actually used BuildSmart on this one. So we, again, always like the idea of off-site, manufactured panels, and tried BuildSmart. So we call it Lego parts, because BuildSmart, and I know it's changed, I haven't followed up with it lately, but when we used it several years ago, it was a very kind of limited palette of panels that we could use. It was only like, so many feet and only 2 or 3 different window sizes that they were offering. So we pretty much tricked the system a little bit here and there, but worked with what they had to offer. And then to the right, that's
and the Lego parts also refers to the fact that the Lego parts are you pretty much are putting parts from different people together, right? Because BuildSmart is delivering walls, and then you still have all the other parts. So
yeah,
you're kind of putting together a lot of parts.
Yeah.
And do you think BuildSmart has improved now? I mean, would you use them again?
Well, the thing is that we really made after this and before the next one to the right, we made the decision to move away from foam. We really wanted to go towards natural materials, and in particular wood fiber insulation. So, just in that regards, we wouldn't want to use BuildSmart again, because the way it works is because it uses EPS insulation, and EPS, and on both sides it has zip, so it's very, very vapor closed, and this only works if you really put a lot of this insulation on the outside of the wall. Otherwise, it doesn't work, because you end up with dew points too far, inside the house, and then there's no way for it to dry out. So, in that way, because you're using this foam, and you also kind of want to have most of that insulation on the outside, so you're increasing your, foam usage. So in that regards, we just made the decision to move away from it. On the other hand, I know back then, I think they changed a little bit, what they can offer in terms of windows and window sizes. So I'm not sure exactly what they offer now. Back then, when we started looking for the next building, actually, You know, in the beginning, we're like, oh, could we do this in Build Smart? But the openings and just the geometry was so complicated that most of it would have been custom fabricated, wouldn't have been their Lego kit of parts. And the moment you kind of move away from their kit of parts back then, I don't want to say anything about now, but back then it was not cost competitive anymore. It became really expensive. So so the next one is a certified pass, or I'm working on the certification, but it's going to be a certified passive house in Chester County. And this is the first one where we used our wall assemblies, or what became the Holzraum wall assemblies, or system. It's not just walls, it's also roof, all interior walls and floors. And we worked with Blueprint Robotics on that.
And where in Chester County?
It's close to
Franklin Township. It's near West Grove.
Yeah.
Oh, West Grove. Okay.
Mm-hmm. Yeah, which is we had a tour about a year ago, and that was very successful. But now it's pretty much done, and yeah, it's been working pretty well.
Well, we might want to visit that too, huh?
Yeah, I can see if the client is open to that.
If you think it's worthy, yeah, okay.
Yeah, I mean, the thing is, since it's almost done, I can send you, I can show you some more pictures. We have some really nice interior pictures. Now that it's done, you know, you don't really see a difference between like the Build Smart or the site build on the inside, because it's all, you know, finished.
Okay.
It did have a nice, it's quite an extensive interior and exterior timber frame system that was woven in. And there were some pretty strong advantages to sort of working with a fully integrated system rather than just walls from one and trusses from another, because the timber frame systems were sort of sharing structural efforts. So they needed to be really integrated, not just for fit and sequencing and installation, but also for structural properties. So that actually worked quite nice. All the pockets and the joinery was perfect, you know, because Ilka and I kind of designed it that way to make sure that it would work with the designers at Blueprint. So that was it was one of the things that we really loved about it, and that's when we started thinking this, you know, we might be onto something here, and this is where it kind of started for us.
Great.
So we just wanted to go through those three different kind of solutions that we found. So the first one is the site build.
So so keep in mind, we're going to talk about these are three solutions, like Ilka said, that we have had at least one or several experiences with at this point. But these are only because Ilka and I we only build high performance and passive houses. So everything I say about these, they don't really apply to a kind of a code compliant build, but these are our experiences. So when it says site built, that means a site built pretty much passive house.
Yeah.
We've built certified passive houses site built. We've also built a good handful of very close or very high performing site built homes. And we've also built a number of SIP homes further back in the lofting history and in my experience that were tight homes, lots of foam, lots of moisture risk. Yeah, and some of it is become famous, but even some of it that's not famous, I know for a fact that I've actually talked to some clients of from a few companies I've worked with that have had some pretty stale buildings that were, you know, they were very energy efficient because you put SIP on a building and you tape it and it is quite tight. But we didn't have ERVs, so we didn't have constant mechanical ventilation with heat exchange. So,
Steve, I'm
anyway.
sorry, I have to interrupt because you're using all these acronyms. So, SIP.
Yeah, so the SIPs are the structural insulated foam panels.
Thank you.
I shouldn't have brought them up because we're not really talking about them, but it's another panelized system. So
well, it's important to us because our architects mentioned SIP
Okay, well, do you want me to tell you briefly how they work?
Only if we have time. I just want to bring it out that
I'll just give you I'll give you 2 minutes on them. I think it's important for you to understand them because there are a lot of architects that still really like them. So you take if you have a timber frame structure, but you don't have to have a timber frame structure to hold them up, you basically take a piece of OSB or plywood that's a 1/2 inch thick, and then you have either a urethane or an EPS or some other foam core. And then there's another skin on the other side. So it's a sandwich with foam in the middle. And those things become your wall panels, your roof panels, and they skin the building. They have openings cut out. They very rarely, maybe they're starting to now, but they never did when we were using them. They didn't have windows installed, so that was all being done in the field. And they deliver a very thermally broken envelope, because they're just one big thermal break, which is a good thing. The problem is that there's no vapor transmission except for where it shouldn't be, which happens like at joints between panels if they aren't taped correctly. So there have been issues where there's some framing that's inside, like where panels come together, and that sometimes can see moisture that's not good because the thing can't really dry. It's like the opposite of vapor open. It's a very closed shell. But that's, I mean, if you guys have questions afterwards, I can give you more information about SIPs. They do go up very quickly. They have an excellent R value. They're fairly cost effective. We won't use them anymore because they're a tremendous carbon load. Their embodied energy is gigantic. And again, the main thing for us is we don't feel safe with them because there's no moisture transmission. They're not open. So site built. So site built passive houses, there are some benefits. There's a lot of upfront coordination, planning, machine investment is significantly reduced. So when you do a site built, the one nice thing about a site built passive house is that you don't really have a lot of upfront design and planning, right? Because it's not off-site manufactured. So that can be nice. That means the client doesn't have to make all these decisions up front. The problem is that when you have that condition, the builder ends up typically taking the brunt, because what happens is, because you haven't been forced to make some of those decisions, you end up making them during construction, and that's when things can kind of surprise the budget and the schedule specifically. The design flexibility is very great. Again, is only limited by the project budget and the team's creativity. So when you site build it, you can build any geometry, and that's a great thing too. Some of the cons on site build are that it is difficult to, it's not cost effective on materials, because you typically are ordering and there's usually quite a bit of waste. The building materials that you're trying to, especially if you're buying higher end building materials and quality lumber and some engineered lumber, is that they're exposed to the weather for quite a while, because it takes a while to frame and then put windows in and insulate. And so, you can basically be out underwater for depending on the size of the house, for 2 or 3 months or more, if it's for a larger house. Like I said, there's quite a bit of material waste. That's been part of the problem of site built, and the schedule delays. For a really good, so the thing about a passive house is, whether it's site built or whatever the mechanisms to get it built is, a passive house is, I always relate it to a high craft house. Like a timber frame requires a certain level of skill, right? I mean, these people train to do the joinery. A passive house is sort of similar. Like, if you're not really going to have a successful passive house in lots of ways if you don't go for a pretty decent builder, because there is attention to detail. Just like Japanese joinery, passive house requires quite a level of detail. And if the problem is that there's some risk if you don't follow through on it. If you don't follow through on your detailing up front with your architect, you can have moisture issues, you can have thermal bridging. You can also lose all the gains that you spent your money on if you don't hit your air quality, your air tightness. So if you don't have a builder that's really kind of committed to following through, then site built can be a problem for passive house. Opportunity for flexibility to make changes in the field by owner. So that sounds great. You know, that is nice that there is some flexibility. But the problem is that just costs money. You know, when you're making changes in the field, it feels great because it's custom, but it's just costing you money or somebody money. And if it's costing the builder money and not you money, you're going to pay for it somewhere else. Next. So then this takes us to our next building type, which is Lego parts. And the Lego parts that we have had experience with are not just the Build Smart panels that did have windows that come in them. And Joel, you mentioned earlier about Holzraum System. All of our windows are installed in the factory. You were looking at a picture of the ICF foundation, the concrete foundation.
Oh,
And those windows, Blueprint Robotics, they actually came and installed those windows for us in the field. But all of the windows, unless they're gigantic, are all very well installed in the factory. It's one of the things we like about the system is it's a really nice window installation. So Lego parts that we've experienced are wall panels with windows installed and exterior insulation. But then we basically are also filling in with maybe a bit of site built, maybe floor framing and sheathing, but then we'll bring in trusses, roof trusses. So a Lego home is sort of like integrated off-site manufactured pieces that you have to put together. And that actually works quite well in the non-passive house world, as you see it all over, right? You see the multifamilies going up, you know, they bring in the walls and they may have the sheathing on them. You know, everything is moving towards that panelized, but the difference between a code compliant panelized home and a passive house is the control layers. So the control layers are not something that a code compliant builder really needs to think about, but the control layers, which are air, water, and thermal, are the part that make passive house difficult. So if you're ordering a bunch of Lego parts and your Build Smart wall is completely passive house just in the wall, that's awesome because it is nice that the windows are good and they have a pretty decent installation as well. But the problem is there's a lot of connection happening outside of the wall. Top of wall, bottom of wall, wall to roof, wall to second floor, wall to floor, you know, and then down to foundation. So there's just a lot more coordination that's required. So again, it kind of comes back to that builder. If you don't have a builder who's really either, number one, has done it and not lost money making passive house, or it's just a really sharp builder that wants to learn it and is really into it, then I would probably be a little leery about Lego parts unless you've got somebody that's really going to like pick up, because Ilka and I put a lot into it to make sure that everything got done. So next. So the cons, I may have already mentioned, confinement to constraints of parts. That was our experience with Build Smart. I know that they do any size window now, so that's a good thing for them. And there are other systems. I mean, it's not just Build Smart. There's systems coming online all the time as customer expansion and diversity increase. So we definitely saw this, and I think that this is the kind of the whole thing about Lego parts. When you have a very cost-effective Lego part, right? So let's just talk about it being Build Smart right now, because so if you have a wall that has the windows in it, it's really only cost-effective if it is sort of standardized to some level, right? As soon as it becomes a customized part, it's not really saving money and we noticed that as soon as you changed from outside the window, the standard window was a white UPVC window and there were like 4 sizes. As soon as you moved away from it in size, the price went up. And then as soon as you moved away from it in color on the inside or outside, the price moved up. If you needed a couple little like wall thicknesses that were different or different height, it really drove the price up. And then all of a sudden we were kind of like, well, what are we saving by the Lego parts all of a sudden? But I want to say we still really enjoyed those walls coming in with the windows. I mean, it is for a passive house. It's pretty critical, I think.
Steve, excuse me for interrupting, but I mean, we are talking about 30 townhomes here.
Yes.
So when you use the word custom, I think that may not apply.
That's true. That's true. If they're all going to be the same, if they're all going to be the same layout, right?
Which they are.
I mean, it's up to what you want, really. I mean, well, let me just keep going. I'm going to come back. It's a really good point, Joel, and I want to come back to it.
Okay.
Because it's perfect, actually. So the next style is a panelized home, which means that, well, in our case, the panelized home actually means the entire system is integrated. And what's great is that we found that when we did our first one with them, with Blueprint Robotics in Baltimore, Maryland, and we brought them the wood fiber, foam-free assemblies, what was really great is that instead of the cost being driven down from standardization, right? So you have a Lego part that if there's not some level of standardization to the components, there's not really, you start to lose the cost savings. But what was really cool about the panelized is that what we found is that rather than the standardization being the geometry of your design, it was about the details. So we call them repeatable details, right? So in other words, we standardized how the wall, like what is the wall assembly? We standardized what our T and corner connections are, all of our framing. They standardized in the factory, how do they handle, a very flexible but like repeatable condition. So that's what is great. So what happens is you don't really pay, as long as it's not a stupid design that has like 8 gazillion, corners for no reason, right? I mean, you're always paying more for corners, but generally this system can achieve kind of endless geometry. So it's very custom and it doesn't really tax you for customization because the savings is in the process instead of the geometry. I don't know if that makes sense. So let me give you one example. A CNC machine, let's say you have a CNC machine and it wants to cut wall studs, right? The CNC machine doesn't care if you give it 5 different wall sizes with 5 different files, or if you give it 1 file and it cuts 5 of the same walls. There's almost no cost savings unless one's just much larger or complicated. So that means that there is no standard wall size. There's no standard window size. There's just the design that you're looking for. And as long as you're smart and you don't, make it super, super complicated, one wall doesn't cost more than the other. So that's what I mean when I say it can be super custom and yet it doesn't have to cost more for some of that. And so for Ilka being an architect, that was gigantic for her. It was liberating for her to move from the Lego parts to like, okay, now I can get back to designing a great building. And I know that all of those kind of pieces of the passive house piece are taken care of and I can focus on the design intent.
Steve, I'm interrupting again.
Yes.
We tried very hard. We went to several prefab and modular factories. One closed down. They were in Pottstown, unfortunately. But that was the big drawback with all these guys. They didn't want to hear about this. What you just said is huge, and that's one of the reasons we're so attracted to what you are offering here.
I think modular is even a more extreme case of what we just were talking about. And Ilka and I Ilka had some experience with modular. I haven't done it, but we've worked with a lot of different people who have. And I think the takeaway for me was that a modular home is quite confining. And I understand the idea is to try to just repeat, but you're really fixing yourself to a box. And I just, that's just, for us, it wasn't really the kind of architecture that we wanted to service. So we just didn't really do it.
Okay.
Did I go back one? I just don't want to make sure so the panelized home, I mean, the controlled environment allows for better precision. That's something that you definitely can benefit from a modular, right? And a Lego. I mean, some of these things, you can definitely see. So here's one piece though. You see the construction administration and collision checks happens virtually before. So this is a part that I also really like, and we're going to talk a little bit more about our design process with Holzraum. The cool thing about that we really learned this through it, is that what's awesome about having the whole building in the model is that you are absolutely forced to vet every decision before you buy a piece of lumber. So in a Lego building, that's not the case. And luckily for Ilka and I, we spent quite a bit of time vetting it, but we still got burned on some things that we hadn't thought through because we underestimated the amount of like coordination that's required when you're putting all those different parts together. So what's awesome about Holzraum and Blueprint is that there's no way they can even think about production start until literally every stick of lumber has been modeled and every fastener has been, accounted for. And so that actually is quite a bit of work up front, and it does move your design. It adds to your design time. So if you said you wanted to break ground in June for a site build, you might as well add a couple months on. So that means you have to kind of think ahead. But the cool thing is that you're really building the building. You're totally building the building, the entire building before. And so what happens is mistakes that would be quite costly, both from the builder and the CA, the construction administration that's required for an architect to come on site because somebody goofed. That is where all that upfront planning, it vets this whole design in a way that can really, really save costs, and also like their unknown costs. The risk of what it can do to a builder and an architect when something got missed in the field is impossible to quantify. So we say it's probably better to spend a little bit more money up front than an unknown, usually much larger amount of money, by just kind of doing it old school, and saying, well, we've got it. We think we have it. Let's see what happens when we get there. And that also comes from Ilka and I doing it. I mean, when we built all those site builds, it was painful. It was very difficult to make money. And so we were learning, but we were like, eventually we have to stop the bleeding, So that's why for Passive House, I mean, it's different if it were code, but for Passive House, it's really important. So I think I talked about all this.
Yep.
Yeah, we can go. So then this is where we kind of ended up. So I think Ilka's going to talk about Holzraum.
Yeah, so, based on all these kind of experiences that we had, we got together and thought about, this kind of Holzraum system by partnering with Blueprint Robotics as the manufacturer. But it's not, it's not only just kind of the manufacturing part that we're kind of offering. We're also, kind of taking it into, like, we can do energy modeling and, doing all the details for architects that maybe have not, invested into being a passive house architect. So they could just kind of come to us and say here, and I actually do that quite often with other even passive house architects that just haven't had, the time, or, haven't really done the investment into learning how to energy model, and they just hire me and say, here, can you do the energy modeling and the passive house certification? So that's kind of a big part of this too. But overall, we sat down and really thought about, okay, what are our ultimate goals besides all, the process and everything and how to get it done, but what is the big picture here? And we came up with our ultimate goal being, to make ultra low carbon, healthy and resilient buildings affordable and accessible to everyone. So that's kind of part of, offering the energy modeling and the detailing and everything, and, pretty much delivering a passive house shell, because all of a sudden builders and architects that, haven't invested into it can do this. So we kind of, we're looking for those puzzle pieces, and the carbon emissions, it was huge because we've been into the passive house for quite a while and realized that passive house only addresses the operational carbon emissions and doesn't really give any guidelines towards embodied carbon. And so we, you know, the operational carbon is just kind of by being energy efficient, having good systems, having a really good envelope so that you lower your you know, usage overall over time. And but the embodied is something that you make the decision in the beginning, and that decision becomes, you know, that's what it is. You'll never be able to get any of this embodied carbon that you just spend back. You know, it's kind of like, yeah, you just pay for it pretty much.
And I mean, Ilka, tell them just a little bit about that, what that means when you're looking at a 12-year lens and you're looking at reducing carbon, a significant piece in buildings. The embodied, you get that carbon benefit immediately, not with over 50 years of operational.
Yeah. So that was very important for us to look at both. And at some point we, you know, when we moved over to the wood fiber and the natural wall and roof assemblies, we did make the conscious decision that, yeah, maybe wood fiber insulation doesn't have as high of a R value as like XPS or, you know, some of the foams. But we said, okay, if that means that we're not going to meet the Passive House certification, for us, it's more important to use the better materials. So that's kind of where we are. We actually haven't had to make that decision yet so far. Everyone who wanted to meet certification has met it, even with wood fiber insulation. But it's, you know, if it, of course, wood fiber is a little bit more expensive than a foam. So if that means you have to scale back a little bit on the R value, we think it's still worth going with the more natural materials.
And that piece that I had mentioned about the PEFC certified, that plays in here because not only are all the wooden materials in our system in a wooden vapor open system, they're all storing carbon, but you can't count that benefit if you don't use you know, certified and like sustainably managed woods, and that was another important part for us. Yeah,
so this is a little graph that was pretty eye-opening to us. I think that's when we really kind of started to understand this, where we, you know, the blue is the operational carbon, the red is the embodied carbon. So if you have a code, and this is probably, I don't know what the date is here.
That's probably 2009 code.
Yeah. So you see that your body carbon, because you just don't put a lot of insulation into these buildings, is pretty low. But then your operational carbon is high. So then the next one is a high performance building with XPS and closed cell spray foam. So you see how much that increases the embodied carbon. Sure, you have overall a little bit less, but again, this really depends on what kind of time frame you're you know, kind of looking this. This is probably a 60-year time frame. If you look at it over 12-year, it's very different.
And you've paid quite a bit more for the second version than the first version, but your actual overall carbon footprint is not really that.
Yeah. So this is another, you know, this is EPS, which is quite a bit better than XPS. But still, you know, you're able to lower it a little bit, but you're still, you know, kind of up there. So if you go to a carbon smart building, which means you, instead of having embodied carbon, you're adding embodied carbon, you're actually deducting, because all of a sudden your materials actually help to, you know, sequester carbon. So this was a pretty good graph for us to just kind of get into this. Second puzzle piece, health and building resilience. You know, we just wanted to have a wall assembly that is really safe in terms of moisture and mold risk, and which, you know, results in better air quality. And also, you know, looking towards building resiliency, looking towards, you know, how does the climate change and what does that mean for us? And for us, that meant really looking into vapor open assemblies, because you always have the opportunity to dry out rather than trapping moisture. So this is what we have been working with. we just have a 2x8 or 2x6 stud wall. Then we have wood fiber on the outside. We have a we have structural sheathing on the inside. So this is the big difference. So our structural sheathing, typically it's on the outside. When you drive around and you see those green buildings, that's the sheathing on the outside. In our buildings, it's actually on the inside. So that means that this layer here becomes 3 functions. It is the structural sheathing, it is the airtight layer, and also the vapor retarder. So because it's fairly vapor closed, it has a perm 5 for zip sheathing or OSB, we're reducing the amount of vapor that goes into the wall from the inside. And then on the outside, because we only have the wood fiber sheathing, it's an insulation board, it's very, very vapor open, so it can always dry out to the outside. And then we have, to protect the air layer, we have a service cavity. And Joel, you're right, Build Smart is slightly different. Build Smart doesn't come fully insulated between the studs. So Build Smart delivers open studs pretty much with exterior insulation. Our panels, they have have cellulose insulation on the inside, and that means none of the mechanical, none of electrical work actually goes through the stud wall. We're just kind of, you're able to even renovate afterwards, or whatever you want to do to your wall without actually touching your passive house envelope ever.
Ilka, do you use any rain barrier systems?
Yeah, we actually do. So on the outside of the wood fiber insulation, we're using Styco, and on the outside we are using a Siga membrane, which is also factory applied, and it's a fully adhesive membrane. And what it does is that it kind of overlaps, or it will be overlapping, or you can just tape it pretty easily at the panel seams. Okay. So that was kind of important to us. The wood fiber itself is treated so that it's actually vapor, it's water resistant. So it actually is a WRB in that case. And if you use it side build, it has a tongue and groove on all 4 sides. So it's pretty tight, but because we have the panels, we have panel seams. And it's definitely easier to get everything watertight when we have the membrane on the outside. And then
outside the membrane is a 1x3 batten for the venting and rain screen.
Yeah.
That's it.
And that's factory installed.
Mm-hmm. And then the roof panel is very similar. So it's fully insulated and has a venting level here. So the cellulose, the wood fiber can always dry out. So we did, we knew this wall assembly works in Europe, but we still did a little hygrothermal analysis and compared it to a more regular, I don't know if I can let it run. Oh no, it doesn't run. So this is just a hygrothermal analysis just to make sure that this assembly actually works in our climate, and it does work very, very well. So we're happy about that. So, we're set with our materials, with the layering of the materials, and then we got into the offsite manufacturing part, which was the third project piece to us. And Steve, you wanted to talk about that, right?
Yeah. So we knew we kind of figured out what we wanted to do, and we needed to figure out how we were going to get it made. We wanted to do these vapor open assemblies, and we wanted to make sure. So we found out about Blueprint Robotics around the same time. Well, I guess a year or so in, when we knew we wanted to move to wooden assemblies, but we just weren't really sure how that was going to happen. Can you go to the next slide? Mm-hmm. So we found out about Blueprint Robotics, and they were manufacturing, and they still do, code compliant walls for, at the time, quite a few single families. Now they're doing more multifamily. All of their single family work now, a few years later, runs through Holzraum System, and it's only high performance and passive house with our assemblies. And they really worked with us to kind of come up there. There's quite a German presence in their company. They actually have a U.S. design department, and then they also have a German design department. And I think the CFO is German, and there's a few other Germans. So they were very familiar with our assemblies, which are very German inspired. And so it just worked out really well. And of course, you know, Ilka was able to kind of go back to some of what she kind of came up with, you know, when she was doing her degree in Germany, and it just all kind of blended. So there was a nice synergy on what they knew, what they liked, and what we wanted. And so we were shocked. We said, we like you to do this. We like your machines. They're awesome. And we're sure that you can do very high precision, but we'd like to get rid of, you know, the R-zip foam and all these different things that they were doing. And they shocked us and said, okay. So they worked with us for about a year to really kind of get this thing figured out. And then at one point, after we'd done a few houses with them, is when they decided that we all decided together that it would make sense for us to take that design piece for the single family market. So yeah, so the offsite manufacturing installation, they basically do everything. They fabricate everything. We now do all the design work, and we take all of so we basically are kind of the bridge between Blueprint Robotics and the design intent and the client and the architect and the builders. And manufacturing.
But it's something that they typically do in-house. So people always ask us or get the impression that we're kind of another added piece to the whole thing. But that's not really true, because we're pretty much under Blueprint Robotics. So we're just replacing their design people, just because they just didn't have as much experience with Passive House. And also, you know, they're just set up for these big projects and not necessarily for smaller, custom, you know, single family.
Yeah, they basically just swap out their in-house design costs for our costs. So, you know, it needed to work that way, or else it wouldn't be cost effective. But it has worked quite well, because we can kind of lean on them and they can lean on us. So it's become a really nice, it's almost like we're sort of an extended little design department for them. CNC precision. Yeah, I think we talked about some of this, the standard. I think I've touched on a lot of this. You can go to the next slide. Did you want me? Yeah, this is the sim process. So there's one, did you want me to talk about this real quick, or Ilka?
Yeah, I think this is just kind of what we do. I think we've gone over that.
Yeah, the one thing I was just gonna mention, we haven't really talked about this. So we do this thing. There is one thing that we really love that we've brought. Yeah, this is the sim. So we came up with this single integrated manufacturing model, and you saw, like, you know, you see another example, but that example of the model that has all of the foundation, it had all the structural steel. It has the Passive House perspectives. It's just a different approach, because in my 25 years of working for design departments that do manufacturing, and also our experience with Blueprint, one thing has been true, that is always true, and that is that a design department that is being paid by a manufacturer is awesome at designing what they make. But it's always a challenge for that person who becomes very, very skilled and focused on that kind of design work. It's very difficult to find people that understand what it means to take a completely different set of architecture with, you know, a program and clients and Passive House and a site and a foundation and all those things, and really kind of understand them from a perspective like Ilka and I do. Because she's an architect, I'm a builder. We just know, we have the bruises from what happens when you don't. So that's why we always said from the very beginning that the only way we would add value to the process is if we created a model that really actually built in more than just their parts. And so that's what we mean when we say a single integrated model. And we include in that MEP. So we get MEP content 3D, either we create it from your 2D drawings, or we get it from your architect in the form of a Revit model or some format. And this has become a really big deal for us, and the clients love it and the architects love it, because the problem with MEP is that it's almost never really coordinated with actual 3D structural members, and not just the heavy structural members, but like all of the members. So what we've been able to do is we've been able to do clash detection at a level that usually doesn't come except for on very large scale projects. And we're now bringing that to, you know, townhouses and also single family residences. And it's great. And I mean, it's kind of amazing what we're able to take away. Again, it's reducing the risk of what can happen and what will happen in the field when your plumber gets pissed because he doesn't understand why he has to drill holes through a glue lamp, or you know, or why a pipe is coming up in the middle of a wall junction where there's a bunch of 2-bys. So that is one thing that's been really good for us, and we, you know, we're just getting better and better at it.
We're going to have to wrap this up fairly soon.
Yeah,
Okay.
we're almost done.
Mention that it should be MEPS, S for sprinklers as well. In our particular situation, we're probably going to need to go that route. So
That would all be part of the clash detection.
Yeah.
okay.
So we just wanted to just really quickly just kind of go through the silver green example. So this is pretty much what we get from the architects, you know, just kind of plans. We make the model that Steve just explained out of it with everything in it. We look at even, you know, in this case, it was this vaulted, this groin vault inside that needed to fit with the trusses. So we modeled all of that. This is a different project, but this is kind of how this clash detection works. You know, we kind of go back and say, here, we need some structural elements here. Can you move your pipe over there? So just making sure that everything fits, you know. Another image. This is pretty much what we generate in the program that Blueprint Robotic uses. So this is where then our files get generated from. So these are production files. You see everything is in there. This is actually what then, you know, besides the, so their production files or drawings, and then their machine files, and the machine files get fed in a one way, and then the people that kind of work on these walls, you know, they get these drawings, pin them to the wall, and know exactly what this is. Here, this is showing how they, you know, look a little flustered at this giant arched window. It fit perfectly, which was great. This is another image of blowing in cellulose in the machine that blows in cellulose into the wall cavities. Here again, someone really just kind of checking out the drawings and looking at, you know, if everything's working the way it needs to work. Then we also generate install drawings. So this is what the installer gets on site with all the dimensions and details, you know, air sealing details here. These are all the tapes, where it needs to get taped in order to, you know, be airtight. This is another install drawing for the floor panels. There are numbers of the panels. They get delivered in a certain order, and installer gets, you know, a packing list and knows what's going to come. And then on site, all the panels are getting delivered.
Stop there. Stop right there.
If you're lucky, you have a castle in your backyard.
My favorite slide. That's the Bryn Athyn Cathedral.
Yeah.
In the backyard of this home we live in.
Yeah, yeah. So this side is pretty amazing. So in here, Joel, you see the Ziga membrane on the outside that covers the wood fiber. This is again air sealing. So because panels are going to be set on top of the wall here, you wouldn't be able to tape the wall panels, you know, where they sit up here. So it's kind of a sequencing thing that we think through. So before the panels get set, a leader, a membrane leader has to be put down, and then the panel gets set, and then the leader can get taped to the panels.
Okay.
And then these are the trusses that came in, and that's also something that we modeled and made sure that everything fit the house. And then this is on the inside. This is, you know, this kind of groin vault. And again, since we had the geometry and we knew that it was going to be built 100% like that, because that's something, you know, that you feed the machines. So that's kind of the big difference too, that all of our work would probably not be of a high value for a site build project, because you have a framer on site and they still make decisions, right? So, but since we're dealing with machines, we know they're gonna do exactly what we tell them to do. So we know that if we model it that way, we can also export the geometry and have these, you know, these vaults and everything made. And once they get delivered, it all fits. So that's it. That's the last slide.
And there was one thing I was just going to say, Joel, too, about the MEP is the for your project for single family, Blueprint doesn't do the MEP install in the factory, but they do it. They would do it for a project that's multifamily or townhouse like. So that is quite a big advantage for cost and time that we can talk about when, you know, later down the line.
Okay.